My name is Sacha and I'm here to present presentation on a solar power plant for industry in Pakistan which has a capacity of 4 megawatt. Pakistan is a development country and due to current development and accommodates its large population and industry, the country needs an enormous amount of energy to keep things on track. The rise in price of crude oil is affecting not the original people but also damage the economic development of the country. All commercial sector, including agriculture, industrial, transport, domestic energy, have been affected severely due to inflation and causing huge economic loss to the country. As huge dependency on fossil fuel not has an implication for the national economy, but also have led to several environmental hazards like greenhouse gas emission, global warming, CO2 emission, and irregular weather pattern. So, government is increasing reducing carbon emission and decreasing dependence on fossil fuel. So for the demand of photovoltaic technology is rising instantaneously and significantly over the next years. The objective which are being considered before designing this project uh, is to simulate the power system, but also not to simulate the power system, but also suggest the best selection of equipment such as inverters and other components so our system operate efficiently as good quality and pocket friendly renewable energy. The project is specifically designed for Amreli Steel, which is in steel industry in Pakistan, which it will be, and by designing this, the this industry will able to save a huge amount of money that is used to pay KE, which is the electric supply company in Karachi. And after the initial investment, it will generate a reliable power at comparatively at low rates and it is also environmental friendly. So solar power plant designing is based on three factors mainly efficiency, economics and environment friendly. Basically there are three types of solar system. Number one is standalone, number two grid tied and number three hybrid solar system. The on-grid solar system is a system which is without having batteries, while the off-grid solar system is the system which have batteries, but it is independent of grid. But the hybrid solar system consists of both batteries and also connected to grid. Major components of solar systems are the basic component, the solar cell, which is need to design a solar power plant. The sunlight strike a solar uh, panel, uh, which convert into DC electric. Usually, solar cell has a voltage of 0.5 volt across it. To increase the power and cater our demand, these cells are connected in series and parallel combination. Here you can see in the picture, there is a cell which combine to form a module or which also called a panel, and different panel or module combined to form an array. There are basically three types of different solar panel: monocrystalline, polycrystalline, and thin film. The figure shows the types of the solar panels. So we have selected the Trina Solar 5 of 500 watt, which is monocrystalline for this project. The other major, there are some important terms for solar sizing which are given as follow: the solar irradiance, standard testing condition, performance ratio, number of shade, edge effects, pitch or modular zero distance, and seasonal variations which might be considered before designing a solar system. Here we can see the row distance, which is the distance between the two solar panels. There are basically three types of inverter used in solar system. The inverter is a main part of solar system which is used to convert AC energy to DC energy, as the power generated by solar system is DC and use the power used by the appliances or industry in power used by appliances in industry or in any residential home requires an AC energy. So inverter is an important part of solar panel. So there are three types of inverters: micro inverter, string inverter, and centralized inverter. The inverter we use in our project is the Huawei Technologies, which is very good, has a good efficiency for commercial use. It's a centralized, it's a string inverter, uh, and because it has high redundancy, flexibility in faults, and space reduction and reduced DC cable loss. The site we selected for is the steel industry, which is located in Dhabiji near Karachi. E- as we can see in the map, it is situated in the industrial area where is power shortage is not a problem, but the constantly rising pricing of electricity are impacting the financial and economic needs of the institution. So we design a power plant on Homer, and you can see the schematic diagram. Homer calculates the energy balance and give an optimized solution for any power plant with different resources like wind, solar, and hydro also. So, and the site is located in Pakistan, which has the average solar radiation intensity, which is 5 kilowatt per meter square per day, which is very good for solar panels. Here you can see the diagram in which the daily radiation index is shown in all the months. Uh, Now the simulation result, as we can show that the results are, and the result shows that the most of the production of electricity is generated through PV, but and the grid is also used, but as a backup. Mm, And there is the emission analysis of a solar plant shown in the figure, which shows the carbon dioxide and other gases produced throughout the year. The optimal system has the least emission annually, resulting in the reduction of adverse effects on climate. Now the cost analysis. The cost analysis of the system and its component in the optimal system is given as follows. As we know that the system are prioritized based on the net present cost of the system. For industries, cost is the main concern, which is also considered by selecting the optimal system. Here we can see that in the diagram there is a large amount of money, that is approx 8 million rupees is saved, will $8 million will be saved, which in a span of 15 years, if the industries applied the solar system for them. So for now conclusion, as we know that the solar resources are in abundance in Pakistan, so we had designed we had designed this system with photovoltaic panels, which acts as a grid, and the grid acts as a backup. This model includes a converter and solar panel. The data for solar and temperature are taken from NASA Surface Meteorology and NREL Surface Meteorology, which is provided on the Homer Pro software. The design system is optimized based on sensitivity analysis, techno-economic analysis, emission, and cost of energy. The cost optimization is performed for finding the most feasible and optimal system based on net present cost and least cost of energy. Thank you. Here are the references where the information is taken for the project, and that's all from my side. Thank you.